Have you ever wondered how many galaxies exist in the observable universe? Let's start by defining a galaxy. A galaxy is a sprawling space system composed of dust, gas, and countless stars. Imagine billions of these star-studded cities scattered across the vast expanse of the universe. Now, how many such galaxies are there? Well, the answer is staggering. Current estimates suggest there could be around 2 trillion galaxies in the observable universe. Yes, you heard it right, 2 trillion. However, remember, this number is based on what we can observe. The universe is a vast, ever-expanding entity, and our current technology only allows us to peek so far into this cosmic ocean. There's an entire universe out there waiting to be discovered, far beyond what we can currently observe. In the grand scheme of things, we're a tiny speck in a single galaxy among billions. Did you know that not all galaxies are alike? Just as there are different types of people, animals, and planets, there are different types of galaxies too. Galaxies are mainly grouped into 3 categories: elliptical, spiral, and irregular. Elliptical galaxies are round or elongated spheres. They're like the elderly of the galaxy world, filled with older stars and very little dust or gas to create new ones. Spiral galaxies, on the other hand, are quite the opposite. They boast of beautiful swirling arms of stars and gas. This is where our very own galaxy, the Milky Way, falls. It's a barred spiral galaxy, and our solar system is nestled in one of its spiral arms, about 26,000 light-years from the centre. Irregular galaxies are the rebels, not conforming to any specific shape. They're often chaotic in appearance, filled with gas, dust, and a myriad of star-forming regions. Our home, the Milky Way, is but one example of the fascinating diversity of galaxies. Every galaxy has a story to tell, a story of its birth and evolution. Galaxies, such as our own Milky Way, are vast collections of stars, gas, and dust, held together by the invisible bonds of gravity. These grand cosmic cities begin their lives as tiny fluctuations of matter in the early universe. Over time, gravity pulls together these particles of gas and dust, creating a dense region known as a protogalaxy. As this protogalaxy continues to condense, it ignites the birth of stars, lighting up the cosmos in a brilliant display of stellar evolution. But the story doesn't end there. As galaxies grow older, they interact with their cosmic neighbours, merging and colliding in a grand dance choreographed by gravity. This process can dramatically alter a galaxy's shape and size, leading to the diverse array of galaxies we see today. Over billions of years, galaxies undergo a cosmic dance, shaping and reshaping in the vast expanse of space. At the heart of many galaxies lurks a monster, a supermassive black hole. These astronomical titans, millions to billions of times the mass of our Sun, are the quintessence of the extreme. They are so powerful that nothing, not even light, can escape their gravitational pull once crossed the event horizon, their point of no return. But what's the connection between these behemoths and galaxies? Well, it's a bit of a cosmic dance. Many galaxies, including our own Milky Way, have supermassive black holes at their centres. As galaxies form, these black holes grow by feasting on surrounding matter, including stars, gas, and dust. In turn, their immense gravity helps to shape the galaxy around them. And it's not all destructive. The energy released by these black holes during their feeding frenzy can trigger the birth of new stars, contributing to the evolution of galaxies. So, these celestial beasts, as destructive as they may seem, play a crucial role in the life of galaxies. Dark matter and dark energy. They sound like something out of a science fiction novel, don't they? Yet they're as real as the galaxies they influence. Let's delve into their intriguing roles. Dark matter, although invisible, is a beast of burden in the cosmic world. It doesn't interact with light, making it unseen, yet it comprises about 85% of the universe's matter. Its gravitational pull helps galaxies hold their spiral shapes and rotate without falling apart. On the other hand, dark energy, a mysterious force, is responsible for the accelerating expansion of the universe. It affects galaxies by driving them apart over time. Imagine a loaf of raisin bread rising in the oven, with each raisin representing a galaxy. As the dough expands, the distance between the raisins increases. That's dark energy at work. Invisible to us, these mysterious entities wield immense power in shaping the universe. From the smallest dwarf galaxies to the largest ellipticals, the diversity of galaxies is astonishing. Our universe is filled with an array of galaxies, each unique in size and structure. To begin, we might think of the Segway 1, a dwarf galaxy that's considered one of the smallest, with only a few hundred stars. On the opposite end of the spectrum lies IC 1101, an enormous elliptical galaxy containing trillions of stars dwarfing our own Milky Way. Now, how do astronomers make sense of all these galaxies? They classify them based on their shapes and structures. For instance, there are spiral galaxies like our Milky Way, characterized by their flat, rotating disks of stars and gas, with a bulge at the center. Then there are elliptical galaxies, massive spherical or elongated systems composed mostly of older stars and little gas or dust. Finally, we have irregular galaxies, which lack a distinct shape and are often chaotic in appearance. But let's not forget about the intriguing lenticular galaxies. These hybrids of spiral and elliptical galaxies are an enigma, with a disk-like structure but little to no gas, making them a fascinating area of research. Speaking of research, let's touch upon the current theories and research areas related to the study of galaxies. Scientists are actively studying galaxy formation and evolution, striving to understand how galaxies have changed over billions of years. They're also investigating the role of dark matter and dark energy in shaping galaxies and their behaviors. Another hot topic is the study of supermassive black holes and their connection to galaxies. It seems that most, if not all, galaxies have a supermassive black hole at their centers. The intriguing relationship between these black holes and their host galaxies is a tantalizing puzzle for astronomers. Our understanding of galaxies continues to evolve, with new discoveries and theories reshaping our view of the cosmos. So as we gaze up at the night sky, let's remember that each point of light may be a galaxy with its own unique story waiting to be discovered.